Hey, pre-calc, let's dive in and make the answer key for Unit 2, Lesson 2. This unit was all about completing the square, but yeah, we'll see how these problems progress through this. So we've got the graph of g of x here, so write the equation for this function. So yeah, sure, g of x would be equal to, so here's the thing, is that we have the vertex here. We could write this using intercepts. We could write it using vertex form. So here's the thing, is that the x-intercept here is at -5. So that's how we record that. Now this doesn't make a quadratic unless we have another part here. And so it's like, what would that other part be? Well, let's see, what if we wrote this in vertex form? Well, our h value, our h and our k value would be -5, comma 0, nothing. So if we wrote it in vertex form, we would have x plus 5 and then plus nothing. This is an equation for it. And then when you look at this, if we double check to see, is there a scale factor applied to this? You go 1 unit over, it goes up 1. You go 2 units over, it goes up 4. This is, with that is a way of double checking to see, is there an a value? No, there isn't. This is a standard quadratic function. It's just been shifted 5 units to the right. There's that shift. So that's our equation. So what does that mean for this? Well, it means that there would be a second x plus 5 to then make it a quadratic and to have that x term squared. And this would be that like simplified way of writing it, just this. We don't need that little plus 0. Boom. Okay. So yeah, today was all about seeing that when we have a quadratic function and its vertex hits that x-axis at it exactly, the vertex is on the x-axis and it is the intercept, that's going to be a perfect square. It's going to be a perfect square. We then move and we use that to keep going with this, to complete the square, to find the k value when this vertex isn't here. That's really the root of what we're doing. Okay, so it says, all right, the graph of which of these quadratics does not have a vertex on the x-axis. So we're looking for that. So this one, it's got that double pair of factors. It is a complete square, perfect square. So if this part right here is a perfect square, then that means the vertex will be on this axis, because a perfect square, it only have 1 0. And the only way for this to have 1 0 is if the vertex is the 0. This only has 1 0 at x equals -2. So does not, that one is, it is a perfect square, and it does have the vertex on the x-axis because there's only one. Okay, so we come to this. This has only one value of a +3. Again, that's being squared, so we'd have 2 sets of the same thing. We just get one value. That means the vertex is on the x-axis. We look at this one. Well, let's skip that one. Let's go down to this. Okay, we got a +4 and a -4. That means that we have x zeros at 4 and -4. Okay, so this one, it's not a perfect square. It's this is one of those where we have 2 zeros, and that means on the graph, well, here and here at 4 and -4, we're going to have 2 zeros, and the vertex can't be. That's the one. The vertex does not lie on the x-axis. Let's back up to this one. How can we check to see if this is a perfect square? Well, like we saw in class, we should be able to show this as a visual. If I took this x squared and see that as an x times an x to get an x squared. X times x makes x squared. And then this 8x, if I took that and split it in half and put 4 of them here and 4 of them here, and we get 1, 2, 3, 4 x's, and 1, 2, 3, 4 x's there. If this was a perfect square of x plus 4 and an x plus 4 on this side, then we will have a perfect number of unit blocks in here. And what's 4 times 4? It is 16. It is a perfect square. So this could be rewritten as x plus 4 times x plus 4, or x plus 4 squared, and that one is one where the vertex would be on the x-axis because there is only one x-intercept, and that's the only way that can happen. Again, I am teaching through going over these. I'm teaching you also parts of the lesson that we saw for those who weren't in class today. Identify the vertex of this. Okay, well, okay, so what we saw here is we focus on these and we complete the square visually. We're looking for, you know, what part squared, what squared would end up creating this. Well, if we took this and cut it in half, we would get an x minus, half of 16. Half of 16 is 8. Half of 16 is 8. So we'd have an x minus 8 and an x minus 8. And if we were to split this up and make it a square, that is a square because this length is equal to that length. We have two sets of these. So we would get our x squared. We would get a negative 8x and a negative 8x. That would combine to make the 16x. And negative 8 times negative 8 does make 64. So there's the visual check. There's the visual check. Identify the vertex. So here's the thing. Nothing else is being added onto this. This is vertex form. There's our h, there's our k, and it's always subtracting the h value. So the h value here is positive. A positive 8, and our k value is 0. That is where our vertex is. Okay? Our vertex is at 8, 0. Precisely. Because it is a perfect square, the vertex lies on the x-axis. Okay. Does the graph have a vertex on the x-axis? So we look at completing the square here. I am going to continue with the visuals. All right, so if we were to have a square, we would have an x and an x to make that square. And then 10x, well, that would get split in half to a 5 and a 5. So we'd have 5x here, we'd have 5x here. This would be our x squared part. In the corner, 5 times 5 would make 25. Do we have 25? No. We have 21. That means that 21, 22, 23, 24, 25, we're missing 4 blocks to complete that square. We are short 4 blocks. So no. The big answer here is no. Let's go ahead and go above and beyond the answer. What would our vertex form be written in? Well, we would have y equals x plus 5 squared. Okay, that's but it's 4 units less than that perfect square. So we have the perfect square, but because we only have 21 units, not 25 units, we are 4 shy, and that means that our vertex would be at the coordinate -5, -4. And that is not on the x-axis. All right, we'll move on. Okay. All right. This problem right here with Anita, it's got a lot of questions, but it is the reason I went over this is because it definitely hinges on the visual model here. So Anita is representing the equation y equals 3x squared. Ooh, 3x squared. Okay, plus 12x plus 20 is tiles to convert the quadratic into vertex form. Yeah, there's other ways of doing this, but this is a visual. So it says, why did she need to make 3 diagrams? So because she has 3x squareds, there need to be 1, 2, 3 identical diagrams, 3 sets of squareds of x squareds, 3 sets of diagrams, x squareds, okay? It really, that is a scale factor that's getting applied. Now, when we look at we have 12 x's to divide up among 3 of these. That means each one of these is going to get 4 x's. In order to arrange those blocks, I would have 2 x's here, and I would have 2 x's here, and that would make this a square. That is an x plus 2 and an x plus 2. And so we would have another one over here. We'd have another x plus 2, okay? All right, let's just complete x plus 2, and an x plus 2, x plus 2. All right, and so if we complete the diagrams here, we would have 2 x's, 2 x's, 2 x's, 2 x's, 2 x's, 2 x's, 2, 4, 6, 8, 10, 12. 12 x's are taken care of in the diagram, and so are 3 x squareds. Now, when we do this, 2 times 2 would make 4, okay? And another 2 times 2 would make 4 units, and another 4 units. 4, 8, 12. We would need 12 units to make up this diagram, but we have 20. If we take away those 12 and put them in the diagram, we would have extra 8 units extra. Okay, so, all right. Why did she need to make 3 diagrams? Because she has three of these x squareds, okay? And if we're trying to complete the square, we are trying to complete 3 identical diagrams, okay? How many x tiles go to each diagram? Well, again, we had 12 x's, but we're dividing them by 3. They each got 4 x's in each one, 2, 2, all right? What is the length and width of each diagram? And x plus 2 is the length and width for each side of the square. What is the x-coordinate of the vertex? Well, right there, that is the x-coordinate, but it always has a subtraction sign, so it would be -2, so that when we did subtracting a -2, we get +2, so it would be right there at -2. And then it says how many unit squares are needed to complete the diagram. There, we already answered that. That is 8. And then what is the y-coordinate of the vertex? Well, all right, the y-coordinate, that 8 is the y-coordinate of the vertex. Altogether, we would be able to say, that's our answer, is 8 for this one. Yep. Oh, yeah. This says how many unit squares are needed to complete each diagram. We saw that, 4, 4, and 4. Sorry, the answer for this one is 4. And the how many extra is the 8, and that is our thing. Altogether, our equation if we were to take this and quickly convert it into this like factored form, we look at this, we go 3x squared. Okay, so there's going to be a 3. Each of these squares are going to be the same. We take this and divide that by 3, and that gives us our, okay, so that gives us the 4, but the 4 has to be split into equal parts, so that gives us the 2. So there's our x plus 2. All right, and then taking that, 2 times 2, squaring it to get 4 times 3 diagrams gives us 12, but we had 20 units, so we have 8 extra units. There's a plus here because we have 8 extra units. Just wrapping this up, the vertex would be at -2, 8. Okay, this is just wrapping up everything, pulling all of the strings together. So let's see. So Anita has x squared, b, and c of these. So we're just using the letters here. This is a pretty important thing. All right, she wants to rearrange the tiles into the diagram. How many diagrams should she make? Well, whatever A is, that's how many diagrams she should make. A diagrams. We saw that up here when it was 3. Okay. How many x tiles will go in the diagram? Well, you're taking that b value, and you're taking the b value and dividing it by the a value, just like we took up here, and we did 12 divided by 3. Okay. How many of those x tiles would be needed for the width? So that's now taking this and cutting it in half. So I'm going to answer that up here. That would be taking half of the b, whatever you got when you do b divided by a. That's the same as b divided by 2. Look at that. We've seen this before. All right, and how many are needed for the length and for the width? It's the same answer. Here's the thing. So like when we factor this out, we get, that's how many tiles we needed here, 2, Okay, so that would be like in our factored form, we would have x, and we would have x plus, well, it's minus x minus b over 2a. We get a number here, and if that value, when we do that, let's see, would this, we would take its opposite value to then get that k value. That's why there's that negative b over 2a that we've seen before. We're rooting this deeply into a physical diagram and seeing that that's that constant there that gives us our h value that we talked about before. It comes from squaring that. Okay, anyway, and then what is the length and width of the diagram? The length and the width of the diagram is that x plus b over 2a. That's our length and width. That gets squared. Oh, sorry, there's our plus. because it's a plus there, when we pull it out, that's when it becomes the opposite. Part E got cut off. Part E is this part that I'm trying to say here, is that H would be equal to the negative, the opposite of B divided by 2A, which again is something that we've seen before. What would our K value be here? So what would our C value? So what we're doing here is we're taking this B divided by 2A, oh man, and we are going to multiply it by itself. Then we're also going to multiply it times the A value. All right, and that will give us the total number of blocks we'll need, and then we find the difference of that with whatever C was. So this is going to be C minus A times, oh my God, A times B 2A, oh boy, squared. That's what this whole value is here when we do that. That's not even asking that, but we should be able to manipulate the equation to get that. Let's move on to these. Write this in vertex form. Complete the square. Divide this in half. We would get negative 6x. That negative 6 would end up getting split into that is the two equal parts. So we would have a x minus 6, that's the part that gets squared. There's our h value. Now we look at negative 6 times negative 6 would be 36, but we're at 43. Boy, oh boy, my brain ain't made for this right now. 43 minus 36 means that we have 7 extra blocks plus 7. That is this in vertex form, okay? Looking at this, again, we take this, we cut this in half. 13 cut in half, well, that's 6.5. All right, so our factored form would be x plus 6.5 squared. We take 6.5 times 6.5, and we're going to get, a 0.25, 42.5, but we're at negative 10, so we want negative 10 minus the answer. Blocks wise, the math is there, is that the number that we would have to have on here is that we are, negative 52.25. Holy moly. Again, what did I do with this? I took this number here and squared it and subtracted that 6.5 squared, subtracted that answer from the 10 minus that answer. And that's how we get this big thing, y equals. Okay, identify the x coordinate of the vertex for this. So here's the thing. If it's the x coordinate, we don't even care about this. We only care about this, and we can get to that number fast. Here's the thing. We got 2 sets of these, okay? So because of that 2x, that means that we're going to take this and split it into 2 diagrams, right? 12 x's. 6 of the x's go here, and if 6 go in this diagram, that means 3 x's go here and 3 x's go here, and 3 x's, do you know what I mean here? So we got an x squared, there's our 2x squareds to complete the square. I don't even care about this right now, but we would end up having, and 3 x's here and 3 x's here. So we split this in half, then we split it in half again, and so we would have an x plus 3. This in factored form would be 2 sets of x plus 3 squared, because this is an x plus 3 by an x plus 3, an x plus 3 by an x plus 3. They are squares. And I kind of want to finish this. The answer, by the way, is a negative 3. That is our h value. But I still want to finish this. Negative 15, we would need 3 times 3, which is 9 here and 9 here. All right, we're going to take that negative 15 and subtract 9 from it, and that's our value that would go at the end of this function. Negative 15 minus 9 more, we would have a minus 24. So there's our k value. Y equals none. Again, this didn't ask for it, but because this is the homework and I'm teaching, the lesson, the repetition is the key to learning. Again, we saw how we're using that a value to split this up and complete the same perfect square over and over. Hope this made sense. Take care, folks. Bye.